Okay. Okay, so what I want to do now is another example. Okay. It's running. Yes, it is. Good, good. Okay, so here's another example. In this case, the only difference is that f of x is negative 8x plus 9. So instead of 8, we have negative 8. Okay, so let's do the same thing. We're doing f of 2 and f of negative 1. Okay? So let's figure out what those are. Well, f of 2, right? Well, again, what do? We replace x by that number, and we do our calculation. So negative 8 times 2, right? That's what we do. And then we add 9. So negative 8 times 2 plus 9. Okay. And we get negative 16 plus 9, which is negative 7. So f of 2 is negative 7. Again, we're replacing x by 2, right, in our formula, and we're calculating. What about over here? It's the same idea, except instead of 2, we have negative 1. We're replacing x by negative 1, right? F of negative 1, you replace x by negative 1, and we do our calculation. Doing so, we get this, 8 plus 9, which of course equals 17. Good. Okay. All right. So we got that. So that's evaluating a function. Now, what we want to do is find x so that f of x is 5. Now, hopefully you didn't see it yet, but how would you do this? Well, it's just like before, right? We set the function equal to 5 and we find x. So in other words, we set the whole thing here equal to 5, right? And we have to figure out what x is. Okay. So we solve for x. So we're solving an equation involving a function. Good. Okay, so here's what we do. We're solving that equation, right? Okay, so it's just like before. We want x all alone, right? That's what we want. We get the 9 out of there. Then, we get the 9 out of there. We subtract 9. So we have negative 8x is negative 4. All I did was I brought it over one space, the negative 8x. Divide by negative 8, as you can see. And we get x equals 4 over 8, which of course is the same thing as 1 over 2. So that's what we get. So we get a half in that case. All right, that's good. Okay, that's good. All right. That's with formulas, okay? That's with formulas. Now, what I want to do is I'm going to show you what the graph of a function is. Now, I don't know if anyone here had me for Math 104 or another class, but I'm going by the textbook here, not to reproduce the textbook, but basically, I'm not going to go into the graph as much as I would in another math class. So I'm going to present it, what the graph is. But I'm only really going to go into it as much as the book does. But anyway, suppose f is a function. Then on the graph of a function, it's all the points in this form. That should be a comma there. Let me just fix that. Come on. There we go. It's all the points in the form x comma f of x, or if you want, input comma output. That's what the graph of a function is. It's all these points plotted in the Cartesian plane. Okay? It's all the points plotted in the Cartesian plane. So you're looking at all these points where x could be any input you want, and you get the corresponding output. So that's what's happening here. Okay, good. Again, the domain is all possible inputs. Now you might be thinking, why should we even have a graph? I mean, we have a formula or in words what the function is doing. Why would we need a graph? Well, it's kind of like the old saying, a picture is worth 1,000 words. In other words, we can learn a lot about a function by considering its graph. We can learn a lot about it. You could learn, for instance, what's in the domain, what the range is, where the function achieves its biggest value, where it's increasing or decreasing, things like that. You can learn a lot about a function from its graph. Okay? All right. So this is what. So for instance, I don't know what this function is. Okay, but there's just an example of a graph. So here I put b, although I put it over this, but this is just the idea. So for instance, from here, if I looked at 3, when x is 3, right, I go up to the graph, and then I'm going to move to the y-axis, but we can, actually, let me say it again. When x is 3, we find 3 on the x-axis, we move up or down, but up in this case, to the graph, and we get 2. So this is saying that f of 3 is about 2, or a little less than 2 maybe. But basically from a graph, you can get the different outputs, is what I'm saying. Or if you want, maybe this will be good. F of 0, which is over here, since the graph is at 0, it passes through this point, which is the origin. F of 0 is 0. So I think when I said f of 3, I might have been off a little, but that's okay. Anyway, let's look at this better example. So here we have a graph of f, right? And we have some points I circled there, as you can see. So from the graph, 3, 2 is on this graph, as you can see. Since 3, 2 is on the graph, that tells us f of 3 has to be 2. F of 3 is 2. That's what this is saying. Okay. Now, what about 1? Well, f of 1, that's also going to be 2, right? Because the point 1, 2 is on the graph. So f of 1 is 2. That's also on the graph. So from a graph, you can get outputs. You just have to read a graph. You can get outputs. F of 2, is that equal to anything? Well, notice we have the point 2, 1 on the graph. So f of 2 has to be 1. So we can learn a lot about a graph. We can learn a lot about a function from its graph, as you can see. Okay. Right. Notice that the graph is never below the x-axis, never below 0. So the outputs are never negative. So you can learn a lot about it. All right, that's fun. Here's another example. Let's say we want to know what f of 0 is, or you could probably tell what it is from this point over here, right? But basically, we get f of 0 is 3. I mean, yeah, you could tell because the point 0, 3 is on the graph. What you can also do is this. If you go to 0, right, on the x-axis, you have to go up or down vertically to the graph. So in this case, we go up, and we hit the graph at 3. So f of 0 is 3. Good. Okay. Notice also, I hope you could see it, if we go to 4, right, and we go up to the graph, here you also get f of 4 is 3, right? Because you go up 3 units until you're at 3. So f of 4 is also 3. So we have f of 0 is 3, as you can see. And I didn't put it on the slide, but f of 4, actually, let me write down now. Over here. But we also have f of 4 is 3. So, okay, we can learn a lot about it. Okay, that's fun. Let's look at the same graph, but look at something else. What would f of 1 be? Well, f of 1 is 0, and why is that? Well, look where the graph is. At 1, the graph is on the x-axis. Or maybe this is better to say, when x is 1, the graph crosses the x-axis. The x-axis corresponds to 0, to y value 0. So f of 1, it's 0. We also have f of 2, right? We go to 2. We go down until we get to the graph, and we end up at -1. So f of 2 is -1. Notice f of 3 is also 0. Right? How do I know that? Because over here, right, you can see that f of 3 is 0 because the graph crosses the x-axis at 3. And the x-axis corresponds to when y is 0. So we also have f of 3 is 0. Oh boy. Okay. So we have that. All right, let me okay. Get to this in a second. Let me just pause the recording.